All right, hello everybody. This is Mr. Baker, one of the Common Core 2 math teachers. Just going to go back through how to solve for a side of a triangle given one angle and one side of that right triangle using some of the trig ratios that we have seen before. So I'm going to show you one way that we'll do it using sine, and then you guys can figure out possibly how to do it maybe with cosine on your own. So looking at this example here, we're given a right triangle. Let's go ahead and label this right triangle as ABC. Okay? We're given a right triangle. We know that AB is equal to 17. And what they ask us to solve for is to solve for this x value, which we know that x is equal to something. But it's going to be the length of AC. Now, to solve this using the trigonometric ratios that you've learned about today, we need to select a given angle. Now, the given angle that is given is going to be one of these two angles. We have a right angle and this 60 degrees. Now, for the sake of using our trigonometric ratios, the given angle will never be equal to my right angle. Going into next week, we might be using some trig ratios of a 90-degree angle, but for the purpose of solving a right triangle, we won't select that angle to be the right angle. In this case, our selected angle is going to be 60 degrees. Now, step 2, I'm going to label my sides. So to figure out what is opposite of what's adjacent to what's the hypotenuse, we need to refer to my selected or given angle. Looking at this triangle, we have 60 degrees, and we think of the opposite side as the side that is not touching this angle. Meaning, if I were to form this angle here, we can see that this 17 is part of that, and this side right here helps me to form that 60-degree angle. The side that does not help me to form that 60-degree angle, my opposite side, is this part right here. We'll label that opposite. So x is my opposite side. We know the hypotenuse is opposite the right angle, so 17, this side must be my hypotenuse. So to help me remember we label this as A, B, C. AB, in this case, is my hypotenuse. We said that AC, that x value, is my opposite side. And then whatever's left over, meaning BC, must be my adjacent side. Okay. We have hypotenuse, opposite, adjacent. Give you a reminder of where those vertices are for this triangle. That's A, B, and C. Okay. Now, adjacent, hypotenuse, opposite. We labeled these sides. Good to go. Now, to decide which trigonometric ratio I'm going to use to help me solve for that x value, I need to think about what's given to me. First, we're solving for that opposite side. We are given the hypotenuse. So when I'm thinking about what trig ratio involves the opposite and the hypotenuse, I have to go back up here and realize, oh, SOHCAHTOA, sine deals with opposite and the hypotenuse. So, flipping back over, that ratio that I would set up is the sine, since it is opposite, over the hypotenuse. Now, we have to set up the proportion correctly to do so. So to set up that proportion, I would take the sine of 60 degrees, that angle, that starting angle, that selected angle, the given angle, is equal to whatever my opposite side is, x, over the hypotenuse, 17. From here, we solve the proportion. Just like any equation, we need to isolate x on one side of the equation. So I would multiply both sides by 17. These 17s cancel, and I'm left with 17 times the sine of 60 degrees is equal to x. If you were to plug this in your calculator, using that sine symbol, that sine button should be right under the apps button on your calculator, and multiply it by 17, you should get something in the neighborhood of 14 point some numbers. Now, based off of your teacher, you might find that they use, or Mr. Ruger, or might use a couple decimal places. I use 3 decimal places in my class. So for those of you guys who have me, you already saw this in class, and you can give the more precise answer. Hope that helps as a guide, and please feel free to use it on the homework coming up. Y'all have a good one.